All right, welcome. Can you hear me? Cool. So it's almost 2 o'clock. The midterm is launched, and I'll show you how to access that now. So I'll stop this share and share my web browser. So here's your Canvas page. I'll put it in student view to make sure it actually works for y'all. Logistics, personal energy use, thermodynamics, societal energy use. And then below that is the take-home midterm. So it's down here. If you click this, you should have access to it. It's this PDF here. It's due Friday, just before midnight, like 11:59 p.m. And so you have 5 days, a work week to do it, and give it a click and start early. Open book, open notes, open lecture. Just no collaboration with anybody else. Do it on your own. Tomorrow and Wednesday, I'm going to launch a short true-false quiz that's available on Canvas. I'll launch it tomorrow, and you'll have until Wednesday to do it. So you have 2 days to do that. It's only like 5 questions or something. So that's just a little rider on top of the midterm to, force you all to look at the midterm and to keep people from working together as much as I can do. Any questions about that? Get the chat open.
Is it kind of like you can do some of the quiz, if you have to go leave and then do something else, you can do that?
Yeah, I'll have it open for like 48 hours or something. Maybe like,
so we can just drop in and out of the quiz.
Yeah.
Okay.
Yeah. But it should be one of those true false quizzes where you kind of like, you know it or you don't. Yeah. And it'll just cover thermodynamics mainly. Yeah, so please have a look at the midterm, either during lecture right now, and if you have questions at the end of lecture, I'll field a few of them. I'll ask, 10 minutes before lecture's over. And then I see a question in the chat. I'll get to it in a second. And then be sure to look at it before Wednesday so that we can discuss it in class together. I'm happy to help navigate questions in class because that's fair. So everybody's there together. We can spend a little time Friday as well. Question from the chat is the midterm timed? Yes, you have 5 days to do it. Is the true false portion timed? Yes, that'll be launched tomorrow and you'll have 2 days to do it. I hated taking tests when I was in college, so I'm trying to remove the anxiety from it. I'm here to test knowledge, not, how quickly you can act under pressure. Yeah. And seriously, when I write scientific papers, it's not like you have to do this in an hour or you can't submit the paper to a journal. Nothing in life works that way. I don't understand why we test that way. Can we email you with questions about it when they come up? Yeah, but I'll only discuss them in class. And if I'm absent-minded and forget about your email, then I suppose that's on me, but you're the one that suffers from it. So maybe bring the questions to class. Okay. Yeah, ask questions either in the chat or directly as we go through the lecture, but let's get going. So today we're going to talk about oil, and yeah, it's the primary fuel we use to power society. Oil, then gas, then coal at this point. Let's look at the greatest oil producers in America. Share screen, Chrome, top oil producing countries. Yeah, that's what I thought. So it's United States. That's a new development. That's only happened in about the last 10 years or so. Ever since the 70s, our oil production was declining. And then with the advent of horizontal drilling and fracking in the 2000s, now we're able to tap into a tremendous wealth of oil that's present in our country. Followed by Saudi Arabia and Russia. Before, there was big players like Mexico and Nigeria in the 2000s, but a lot of Mexican oil has been tapped out, at least the conventional oil, and we'll talk about what conventional oil means in a second. And then Nigeria, a lot of their oil is now going to Europe rather than the United States. Okay, saw something else in the chat, but I lost it. Didn't we have a big oil crisis in the 80s? Yeah, it started in the late 70s with destabilization in the Middle East, and that's where the majority of our oil came from. And it got to the point where there's like gasoline rationing, even numbered license plates. We'll have Joel Swisher. He's going to do a guest lecture towards the end of class. He'll talk more about that because he was actually alive during it. It's just something I would read about. Okay, let's get into the lecture now. Where'd my Zoom go? So tiring doing all this Zoom stuff. Share screen, PowerPoint. Cool. All right. These are oil derricks. They go up and down. They pump air in, or later on they can pump water or steam into the oil field. And then when they retract, they create suction. So they pressurize the oil reservoir, and then they create suction to draw oil up to the surface. So this isn't what drills for oil. This is what produces the oil. Those derricks you may see if you go like drive Highway 101 from SF to LA. You'll see them around like Bakersfield. Okay, so what's so special about oil? It's energy density, and it's very easy to transport and move. It's this fluid that you can put in a bucket or a pipe and carry it around with you, or send it down a pipe and deliver it, and it holds a tremendous amount of energy within it per unit weight, per unit volume. So it's this amazing energy carrier. We can compare it to a few other things. Wood is 17 megajoules per kilogram, so that's how much energy there is per unit mass. We call like a kilowatt hour is 3.6 megajoules, so this is like 5 or so, 5 kilowatt hours. Gasoline is over twice that, so it's just really, really energetically dense. Coal is somewhere in between. Coal is just a dehydrated wood, basically. You take wood and get rid of all the hydrogen, and you're just left with carbon. Then we can compare this to a lithium-ion battery, and look at it's a factor of 20 less dense than gasoline. Again, that's why the entire base of a Tesla is the battery, and whereas a Honda Civic, which can go the same range, 350 miles, has a gas tank like this big, a 10-gallon gas tank.
Why is the lithium ion battery so low?
Because the electrochemical nature of it. So you're combining lithium ions with oxygen, and that electromagnetic reaction just doesn't have a lot of energy per unit weight. Plus, with lithium ion batteries, you have to build substrates and meshes and pastes to contain it all, and then you have to build a container around it. So all this, it has all these extra materials that don't contribute to energy delivery, just to hold it. And you have to have half the battery that's, for all intents and purposes, useless, because as the battery discharges, the chemistry moves to one half of the battery. Then when you charge it, it moves back to the other half of the battery. So there's half of it that just doesn't do anything. All right. So that's a little bit on why it's so useful. Super energetically dense, and you can move it around very quickly. But in defense of the lithium-ion battery, an electric car is much, much more efficient at converting that energy in the battery to motion than a gasoline-powered car is. So electric car are over 50% efficient, closer to like 89% efficient, and gasoline powered cars are only 20% efficient. Okay. The other special thing about oil is the entire lifeblood of the chemical industry. So it's so surprising how much stuff is actually made from oil or a derivative from oil. I had no idea before I started, getting into the energy game. Basically, all pharmaceuticals, like all the pills you buy at a pharmacy, over the counter or otherwise, are organic chemistry. And where do they get the organic substrates? They get it from oil, because oil is just a bunch of carbons and hydrogens, and you can, as a chemist, you can rearrange those to produce different, compounds, medical compounds. The entire chemical industry, adhesive industry, plastics industry, it's all oil based. And so this very ugly table here shows all the different things that come from oil. Yeah, you can look at it and get a little depressed. It's all stuff you don't really want. Artificial turf, it's all junk, but it's junk that we all have, and it's all over the place, right? If when I actually give this lecture at school, we can just look around the classroom and see like most of the entire classroom is made out of oil. We're sitting on plastic chairs. Our tables are fake wood with plastic veneers. The computer is made out of plastic. The projector is made out of plastic. The screen that the projector is shining on is made out of plastic. It's crazy when you think about driving your car down the road. You put gasoline in your car, which comes from oil. Your tires are synthetic, mainly synthetic rubber with some natural rubber made out of oil. And it's driving on a road, which is rock and tar. That's what asphalt is. And tar is just oil. And so your car is made out of a lot of plastic. So you're like filling a car made out of oil with oil, driving on tires made out of oil on a road made out of oil. Where is oil in this chart? These are all products of oil. And we'll talk about how you go from raw crude oil to some of these products in a second.
He was talking about from the last table.
Oh, thank you. I was a little depressed. I'm like, come on, man, this is this is all oil. So it's not on here. So here's diesel, here's gasoline. Yeah, crude oil, I'm not seeing it. It's going to be more dense than diesel, so probably up here somewhere, because oil is just this big hydrocarbon soup of all different hydrocarbons. That's carbon surrounded by hydrogens, all the way from the lightest thing, which is methane, to very heavy things like tar. I'll get into that in a sec. All right, so it's available nearly everywhere. Anywhere we look in the planet, we find oil, or at least any region we look on the planet, we find oil. It's formed just whenever there's a sea that is then dried up. Talk about that in a sec. And there's infrastructure all over the place, because we've been building oil infrastructure for the last 120 years or so, and so there's just huge infrastructure everywhere. I won't waste the time in lecture traveling around Google Maps, but have a look at particularly the Persian Gulf. You'll see massive oil infrastructure all over the place. Houston would be another interesting place to look at. We also have huge oil infrastructure just here locally. March Point down in Anacortes, and then Cherry Point with BP and ConocoPhillips 66 just north of us. So it's easily moved around, so easily to move around that we move it around the entire globe constantly. And so these are tracking major oil trade movements in 2016. So what looks like to be a huge source of oil?
Saudi Arabia.
Yeah, so it's huge spread of oil coming out of Saudi Arabia, and this includes like Qatar and Dubai. Another big sources of oil is Burkina Faso, down in Indonesia, Russia up here, and then United States is just a big oil trading hub. We produce oil, we import, we export oil, we price oil. Oil is priced in US dollars throughout the entire globe. It's something called the petrodollar, and it was established shortly after World War II, and and here's Nigeria too with a huge source. And so whenever oil is traded throughout the world, you have to first, if you want to buy oil, and say you're from India, you want to buy oil, you first have to convert your money into dollars, and then you can buy oil. It's actually artificially boosts our currency and makes it a very stable currency, because it's yes, we have fiat currency, meaning that it's just an idea that we say, okay, a dollar is a dollar, and some like ideological construct. But in a sense, it's backed by oil. There are nation states that are obviously upset with that, because they would rather just trade oil directly. And so it's a source of geopolitical tension. Okay, yeah, big trades between Canada. So we import a lot of oil from Canada. All the gasoline you consume here in Bellingham is all Canadian in origin. In particular, it's from the Athabascan tar sands up here near Fort McMurray. Talk about tar sands in a second. Europe doesn't really have much oil production at all, aside from the North Sea up here in Norway. Yeah, I don't think we get much Alaskan oil. I think most of that goes down to LA. This is just what I heard from JT at Phillips 66 when I was talking to him up at the refinery, that we just basically have Canadian oil. There's this island here, the Scottish Isle, I forget what it's called, like Sheffield or Shetland or something. Major oil trading hub here. It's really fascinating. So you should zoom in on that on Google Earth. Why do we export so much oil if we just turn around and import it from other countries? Yeah, good question. It's just the geographic nature of the Americas, right? There's oil on this side, there's oil on this side. It's oil coming from north and south. Here's all of Europe over here and all of Pacific over here. And so it's just economics. How do we make money selling oil, and how do we save money by purchasing it from somewhere else, depending on where you are in America?
Question, why isn't there any, why is Alaska not on this map at all, included in it? Because is that like something that's moving or moving towards starting to use oil there, or
You're
moving
totally
oil
right.
over there?
Yeah, the geographic fidelity of this map isn't that great. So we're looking, this is produced by British Petroleum, and it's just on a country by country basis. There's nothing like internal to the countries. So that's basically going on. Yeah, so this should be down in Houston. This is surprisingly in the right location on the Athabascan tar sands. But yeah, there should be huge production up here in Alaska, huge production here in the Dakotas. Yeah, huge imports in China, huge imports in Japan. All right. So what do we use it for? We already talked about the chemical products that we use oil for, but that's just a small bit of it. I guess it's 25% of it. That's this industrial processes here, that's 25%. But the lion's share is all transportation. So it's fuel for cars and trucks primarily, secondarily airlines, and thirdly trains. Oh, and bunker fuel for shipping. Yeah, so here's light vehicles, trucks, air, and yeah, other stuff. Water means shipping. When you have a barrel of oil and it has 42 gallons, you don't need to memorize that, but it's just kind of strange that it's 42 gallons. It's just another American way of measuring things. Nothing actually makes sense, but it has 42 gallons in it. and 19 of those gallons are turned into gasoline. That's the most valuable product. And so refineries try to convert as much oil as they can to gasoline because you get the most money selling gasoline. And then secondarily, diesel. Thirdly, jet or other products. So these other products are mainly precursors to industrial and chemical processes. So there's something called like naphtha, which is like 2 carbons and 6 hydrogens or something. And so it's this nice precursor to turn into other things. And it's also jet fuel, which is a lower chain carbon as well. More on that in a sec. What changes are made to turn oil to turn it into gasoline? Yeah, good question. We'll get into it. Somebody also said they can see March Point from their house. I heard this sad story where this little boy in Anacortes wanted to go to Disneyland, and his mom said, no, we can't, can't go, this year or something because of coronavirus. And he said, why not? It's right there. I see it every night, because he saw the huge lights of the March Point oil refinery. But it's not Disneyland. Okay, the amount of oil the world is consuming, that's liquids here, has steadily been increasing. Teeny blip due to 2008 recession. There's going to be another blip right now for coronavirus. But in general, the world's consuming more and more oil each passing year and will continue to do so. It's called liquids now because the easy to get oil is no longer available anymore. It's been produced. And so now we do things like tar sands and fracking. And so it's just called liquids. Okay, what do I want to talk about next? I guess we'll just stay on where it comes from and where it goes. So this is where it comes from, is production by region. CPP. Colas CPP. I think that stands for Climate Protection Plan, but I'm not sure. Good question. I can make something up because I'm a professor, but I'll just be honest and say I don't know. So where is it produced? The Middle East, Saudi Arabia, Iran, Kuwait, Qatar, Dubai. Where does it go? Asia Pacific, primarily now, so China, India, Japan. So here's America production really taking off in this last decade due to horizontal drilling and fracking. Production in Europe is basically all constrained to Russia and Ukraine. It's staying pretty constant over the years. And then the big game now is Africa. And there's going to be huge production in Africa going forward. There was a lot of production in South and Central America, but there's thought to be even bigger fields off the west coast of Africa. So today we consume 100 million barrels a day. So what does this look like? This is one of these dumb like John Oliver numbers, but it's like a 20-inch pipe wrapped around the earth twice, or it's and the rate, the power, energy divided by time would be the equivalent of oil exiting that pipe at 2,000 miles an hour. So that's how quickly we're consuming oil. Where is it consumed? Per capita, so this is oil consumption per person, again at country level fidelity, and it's primarily the largest consumption happens in United Arab Emirates, and yeah, Olympic swimming pools, exactly. United Arab Emirates and Saudi Arabia, and that's because of huge subsidies. Like you can basically buy it for free there, the gasoline. And that's why you can YouTube Saudi Arabia street races or something, and they always have these like baller ass cars, and they're flooring it down the highway all the time because the gasoline's for free. But then it's also consumed tremendously in Canada and North America. And that's just because these are wealthy nation states that have very low population density. So we have to use cars to transport ourselves. Europe is also wealthy, but it's much more dense. And so their trains make economic sense. And most people commute and travel by train because it's cheaper than by vehicle. Whereas here it's cheaper to travel by vehicle than train. Korea, I think a lot of their electricity generation is done by oil, similar to Hawaii, but that's changing. But yeah, Korea, when they developed their economy rapidly in the 90s, in the early 2000s, they needed more and more electricity. And at that stage, natural gas wasn't really there yet. So they built a lot of oil electricity gen, which is pretty dirty. So hopefully they start shifting to natural gas, or better yet, renewables. Australia, similar story to US and Canada, just low population density, long way to go. Here's the crude oil prices in 2016. A lot of war and a lot of economic stability is directly tied to oil, because oil is responsible for global trade and global transportation. And so it was discovered in 1857 in Pennsylvania. That's the that's where they started calling it blue barrel of oil rather than black barrel, to differentiate from whale oil. And so it became valuable, and it's also called petroleum because it's rock oil. Petro means rock. And so they discovered, realized that it was a valuable substance, so the price increased rapidly, but then it was discovered in other places, including Russia, Sumatra, Texas, and so the price stabilized. Blip in World War I due to shortages of oil for military, and then relatively stable. Little blip in World War II. Part of big military strategy in World War II was cutting off oil from North Africa to Germany, to the Nazi regime. And so that was why there's a lot of activity in North Africa, a lot of military activity. Establishment of the OPEC oil cartel. So this is oil producing nations that decided to stabilize the price or work together on selling oil to maximize their gains. This was kicked off by the Yom Kippur War and then the Iranian Revolution. And so there's massive spike in oil. So this is the late 70s, and this is where oil rationing happened in the United States. And then there's a lot of efficiency gains and oil stabilization in the 80s. Then the United States invaded Iraq following Iraq's invasion of Kuwait here. And so there's a brief blip, then stabilization and super low oil prices in the late 90s. And then the United States basically ran out of all conventional oil, and we started importing a lot of oil from Nigeria and Mexico and Canada, and the oil price continued to go up, and it peaked just before the recession. Many people argue that it was one of the contributing factors to why the recession happened. People were building these ridiculous homes far from metropolis centers. They were underwater on their mortgage, and also they had to drive too far, and there was a shortage of oil. And so, oil peaked then. Then there's the economic recession, and then the Arab Spring. The different purple revolutions in Egypt, Tunisia, and elsewhere. Oil price went peaked there, and then it's been falling ever since. Again, due to horizontal drilling and fracking, and then it became negative priced in March because of coronavirus. Nobody wanted oil, and now it's still really, really cheap. It's like $30 a barrel or something like that, and that's why gasoline is so cheap right now. So yeah, if you look at a price map of oil, you can basically say something happened whenever you see big changes. Was blue barrel crude oil and black barrel whale oil? Yeah. So that's why oil is labeled as BBL, just stands for blue barrel. So what is oil? Normally I borrow some, we have a lot of oil in the geology department at Western, different samples from different places in the world. And it's not homogeneous, meaning it's not all the same stuff. It's a bunch of different hydrocarbons all in a stew. What do I mean by a hydrocarbon? Let me talk about this for a second longer. So it's mainly all carbon, and those carbon are surrounded by hydrogens in via bonds. And then there's a little extra stuff, nitrogen, oxygen, and sulfur. The sulfur, what largely determines some of the quality of the oil. It's viscosity. You want it runny, so low viscosity, and you want it low sulfur, and that's so-called sweet oil. Why is it called sweet? When the sulfur content in oil increases, it creates hydrogen sulfides and sulfuric acid, and acids are sour, like vinegar that you put on salad. So, the old roughnecks and cowboys in Texas, when they taste the oil, they'd say, is it sweet or sour? If it had sulfur in it, it'd be sour and be less valuable because sulfur is corrosive to, engines and other things like that. Okay, let me stop this, change video. So what do I mean by a hydrocarbon? The simplest hydrocarbon is methane. And that's just a carbon surrounded by 4 hydrogens in kind of a pyramid shape. Octane that gasoline is made out of, up to like 90% or something. How many carbons do you think that has? 8, yeah. Octopus. 1, 2, 3, 4, 5, 6, 7, 8. And then these carbons are all bonded together, and then it's surrounded by hydrogens all the way around, like that. And it doesn't have to be in a straight line like that. Some of them are kinky, don't get excited. Other ones can go in loops. And yeah, so these octane can have all sorts of different shapes, as any of these hydrocarbons can, except for methane. That's going to be dictated by electrochemistry. Diesel has, I don't know how to spell diesel. That doesn't look right. Has 12 carbons, and it continues to build from there all the way up to like tar, which is like 60 carbons. So yeah, oil has all these different types of hydrocarbon. And that's what it is. It's just a big hydrocarbon soup. All right, so we got to do something with that oil. We have to refine it. So here's the refinery down at March Point, in Anacortes. This here, these are big distillation towers. So what is distillation? It's when you boil something with a low boiling point and then capture its gases. So it's converted from the liquid phase to the gas phase. And then you cool those gases down and drip them somewhere. So that's how you make whiskey, right? You have a mash with some alcohol in it, you boil it, the alcohol has a lower boiling point, capture that alcohol, you cool it down, and you drip it somewhere. And that's how you get whiskey. But don't do that at home, because you won't just get ethanol, you'll also get glycol and wood alcohol, and you'll make yourself blind. Distilled water, yeah, so you boil water and capture the pure steam coming off of that and cool it, and then it drops off somewhere, and all the impurities will be left behind in the water. So you can do that with, a solar still. You just put put a tarp, the transparent tarp on top of a bucket of water. The water will evaporate, hit the tarp, and then roll down on one side. And so that's how you can make water if you're stranded on a sailboat somewhere in the middle of the ocean.
Quick question, how efficient is that? Like, is there a percentage you can put on that?
Yes, definitely. I don't know off the top of my head. Hopefully I'll have it somewhere in here later. I definitely had it in that that well to wheel lecture when we were talking about exergy, like how much of the oil actually goes into moving the car forward. So yeah, I think that was like lecture 7, but I'll look at that again. So here's a distillation tower. It's called fractional distillation because it's distilling multiple products simultaneously. And so the way this works is crude oil is pumped in, it's heated, usually with natural gas. In the olden days, they would just heat it with oil itself, kind of cannibalistically. And so the oil is heated up and then put into this distillation tower. So it's hottest near the flame, and at the base of the tower, it's the hottest, and at the top of the tower, it's the coolest. So here's temperature here, and at the base, it's at just around 600 degrees Celsius. And so the heaviest hydrocarbons have the highest boiling point. They're the gummiest stuff. So picture like candle wax, right? You can heat that up and it's not going to boil. It actually just turns to a liquid. It's not until it's actually caught on fire by the wick that it turns into a gas. And so this tar gets heated up and gets runny and is drained out the bottom of the pan. So this is it. These are C70s, so the gummiest stuff. It's called bitumen, and it's used to make roofs. So that's your shingles are just rocks and bitumen, and it's used to make roads. Asphalt is just rocks and bitumen. And then anything that's in the gas phase gets to creep up around these pans and go higher. C20 to C70 starts falling out of gas into the liquid phase. It's distilled at this temperature, and it's collected in these pans and drained off. This is bunker fuel, so really heavy diesels that are used in massive ships like container ships and oil tankers. And so these huge engines get warmed up, and the heat from the engine makes the thick diesel runnier, and then it's combined with air and the pistons, and that's how the engine runs. It's really energetically dense with all those carbons, and that's why it's used. But it's pretty environmentally rapicious because it generates a lot of carbon dioxide when you burn something like that with all those carbons. Going up the distillation column, C20 to C50 falls out here. This is lubricating oil. This is what's used in your engine. You pour it in your car engine or your bike chain. Also makes things like petroleum jelly, like Vaseline, and different shoe polishes, whatever, things like that. So it's you can picture it, right? It's gummy stuff. Going up the distillation tower, now we're at C14. That's what diesel is, that you have in diesel powered cars. Diesels go all the way from C14 to C20. The heavier stuff is used in bigger engines like trucks and trains. Lighter stuff used in cars. A lot of military applications for diesels. Continuing up the distillation tower, now we're past 170 degrees. We're starting to cool down here, and so paraffin falls out of the gas phase into liquid. So this is kerosene. So this is used for oil lamps. It's also used in jets. Jet, it's going to have a combination of naphtha and kerosene, depending on the fuel blend they're using. Yeah, and this is also what you'd have if you have an oil furnace in your house, or your parents do. This is what your oil furnace gets filled with, paraffin or kerosene. You can even run cars. You can run diesel cars off of kerosene. Like when I've been around like Madagascar and Kenya, it's an option you can buy to fill your diesel car up with kerosene. It's not good for your car, but it's super cheap. And if you're hurting on money, then just fill your car with kerosene. Let it roll. Gasoline, this is distilled at 120 degrees Celsius. This is the most valuable product. And so they're trying to target octane, which is C8, but The gasoline you put in your cars, it's going to have some C7s and C10s and things like C9s in it. And this is what gasoline is. You can target higher percentages of octane with like plus and supreme or premium fuel, right? And so if you have a high end engine that's sensitive to that sort of thing, you want to put in closer to pure octane. What would happen if you try to fill your car with oil? Yeah, terrible things, especially if it's a gasoline car, because a gasoline engine is spark ignited. A mixture of octane and air goes into your piston, and then your spark plug makes a spark that lights it on fire and creates an explosion that moves the piston. It would work okay in a diesel powered car because those aren't spark ignited, they're compression ignited. So the piston, when it explodes, it opens up and sucks in diesel and air, and then it falls back down, and that compression increases the pressure and temperature until the diesel air blend is not stable anymore, and it ignites and pops the piston back up. So you could do that with heavier things, like you usually have to convert it. So like biodiesel cars, like if you have like a hippie friend with a bus, they converted to biodiesel. They usually have the biodiesel run over a warming plate first to lower the viscosity, make it more runny, so that it doesn't gum up the engine as much. Yeah, but in general, yeah, you have to have a pretty old-fashioned car, old-fashioned engine to run these sorts of things. Modern cars don't like this at all. Then naphtha, these are the building blocks for pharmacy and industry. So you can take these smaller hydrocarbons that are still pretty stable, and because they're still in the liquid stage, but they're really runny, and use it for chemical precursors. And then finally, the lightest stuff, methane, which is C1, the one carbon, ethane, butane, pentane, or propane. These are all things that are used as in the gaseous state. So natural gas coming into your house, that's methane. Propane in your barbecue or outdoor heater, or if you live, out in the country away from gas lines, then you have a big propane tank usually on the side of your house. So that's all that sort of thing. And then like butane, which is C3, that's what's in like a Bic lighter.
Earlier, you were talking about how the carbon chains can be a different shape. They can be circular, they can be kinked, they can be straight. Does that shape impact this distillation process?
I'm sure it does. I'm sure they have slightly different boiling points, different like latent heats of evaporation, but you're beyond my knowledge as a chemist. I only took Chem 121, 122, 123. So when I talk about chemistry, like, don't listen to a whole lot of what I'm saying. Energy systems I got, but chemistry, man, too much to memorize. That's why I'm a physicist. You just have to remember a few like rules, and then you got it. All right, so how do we make oil? It's dead stuff. It's not dead dinosaurs. Like there's a preview for that that Mark Wahlberg like Deepwater Horizon movie, and his little girl in the movie is like, my dad digs up dead dinosaurs or fights dead dinosaurs or something like that. I guess it's okay for like a little kid to be confused, but a lot of people are actually confused about it. I think because back in the 50s, there's this Sinclair oil company that had a big brontosaurus sign or something. It's not made from dead dinosaurs. It's made from teeny microscopic creatures called diatoms and phytoplankton, little algae things, and little teeny animals. They live their happy life, and then they die and they fall to the seabed. It's called marine snow. Watch any of those Attenborough movies and you can see the marine snow. It's like one of the bases for the food chain deeper in the ocean. And then if it's near a river or some outlet, then seasonally that marine snow, that dead stuff, will get covered with sand or silt or clay, and then another layer will happen, and then another layer of sand, and then another layer of dead stuff, over and over and over again for thousands, tens of thousands, millions of years or whatever, until it gets trapped under enough layer that it can no longer escape. The deeper you go down in the earth, it gets cooked. I'll get to that in a sec. So these are the little diatoms and algae and phytoplankton that make up oil. Just the little things, little creatures. Yeah, so they fall down, builds up. As you get deeper down into the earth, it's warmer and warmer and warmer just due to the geothermal gradient of radioactive decay and residual heat from accretion of the planet. And that dead stuff gets cooked, and so all the water dries off and can leak upwards or elsewhere, and then you're left with just the hydrogen and carbon, the hydrocarbon left. Once it gets cooked enough, it starts to distill in its own right, in a way, going from the solid phase to the liquid phase, and it's less dense than the sand, right? You know, you have your column when you're in second grade where you have like syrup and water and oil, and you can put sand in there too, and you can see how things stratify based on their density. The oil is less dense than the sand, so it starts to rise up. And it just oozes out of the ground. If you go down to like Santa Barbara, Santa Cruz, even like some of the sandstone here in the Olympic Peninsula, you can see oil just coming out of the sand, and it just naturally occurs. To make economically useful oil, you got to cap it with a lid. And so these are different lids that we find in different oil reservoirs. One of the most common ones is a syncline or an anticline. That's just kind of a folded piece of earth. And this cap rock can be like clay or ash, anything that is very low permeability, porosity. So water and things can't flow through it at all. You know, much lower than something like cement you might find on a driveway. That's actually pretty porous. You can pour water on it and see the water go into it. And so this caps it for millions of years, and until you penetrate through that cap rock, and then you can produce that oil. Normal faults can do it as well. These are really cool. These are salt domes. So on an ancient sea, you have a big plain of salt that's left over after the sea has dried up. And salt is actually lighter than rock as well. And so it starts to become buoyant over millions of years and can rise up kind of like a lava lamp and create this big dome of salt that's, you know, kilometers high. And that bucks up the land around it, and surrounding that salt dome in a toroidal, like donut shaped fashion, will be water, oil, and gas in different stratigraphic layers. Look at Iran, southern Iran, just across from the Strait of Hormuz that I talked about the other day, right near the Persian Gulf. You'll see all these big bubbles all over the place, massive geologic structures that are salt domes. They're also in Louisiana and Texas. How hot is the lava lamp ball of sand? Not very, I mean, few, maybe 100, 200 degrees Celsius. Yeah, so it's pretty cool. There's no giant caves or lakes under the ground. Oil isn't this big swimming pool. It's little gummy things between rocks. So it's oil suspended in a rock matrix. How conducive it is to actually get the oil out of the ground is how well connected this rock matrix is. And so that's a measure of its permeability, which is how easy things can flow, and porosity, and that's the size of the little holes that the oil can occupy. And then it also depends on how runny the oil is. So the most valuable oil is, again, sweet, low sulfur, and light. Light means runny. So light, sweet crude is the best kind of oil. And there was that in Texas, but we produced it all. Now the best oil is in Brunei and Texas. I mean, Brunei and Saudi Arabia. That's where the good runny light sweet crude oil is. I think I'm running out of time. So here's a nice syncline here in Ventura, California, and there's even some oil storage tanks and oil derricks on top of it, producing oil there. We find it using seismology. So we set off a bomb, and then we measure the sound waves going through the earth and reflecting. Oil is less dense, and so the sound waves travel through it more slowly than rock. You know, put your ear on your desk and knock on it, and you can hear how quickly sound waves travel through solid things. They don't travel as well through liquids. And so you can measure the time it takes for the sound waves to get back to a couple of reflectors, perform some triangulation, and you can detect where the oil and gas is using seismological mapping. You can also do it with gravity waves, measure density contrast within the earth using satellites going around the planet. Really sophisticated methods. How do we recover it? Well, first we just pump it from the ground. by, well, some places you don't even have to pump it. It's under pressure and you just create a hole and it jets out to the surface. That's what happened in the Deepwater Horizon oil spill in the Gulf of Mexico, the BP disaster. But barring just a gusher, then you have to pump it. You have to increase the pressure with air, and then the oil comes up. When that stops working, you can water flood it. This isn't great for the reservoir. It gums it up. You know, if you mix oil with water, it makes a mess. But you can pump water down there. The oil will float to the top and extract more oil there. After that, you have to use ERO, enhanced oil recovery, and this you inject steam, so hot water, and that hot water lowers the viscosity of the oil. It makes it runnier. It kind of melts it, you know, and so you can extract a few more percentage using this method. And if you go down Highway 101 along Bakersfield, worst town as far as I'm concerned in the world, there is you see these big steam pipes running everywhere, running this huff and puff operation. God, that town smells so horrible. There's massive like feedlots and factory farms and oil production. Terrible place. If you're from Bakersfield, move. Oil production is absolutely massive endeavor. We talked about this before. So these are the biggest machines that humankind has ever made. And these massive oil production platforms. So this is the Thunder Horse oil platform off of Galveston, you know, South Texas. And here are cars. These are the employees loading up on this platform for departure here. So this is, massive cars. I mean, massive platform. If you see here, 1, 2, 3, 4, 5, these are 5 natural gas Brayton turbines. So these are these big power plants that are, you know, downtown in Bellingham. We have like 3 of them downtown. Here's 5 of them just here. So this is, you know, city-sized energy generation here going on. There's big helicopter pad, et cetera, et cetera. So, and these are GPS satellite controlled. They travel, you know, deep into the Gulf. Absolutely amazing structures. This one incidentally almost sank at a oil field called Casa Perdido, which is Spanish for lost cause. I thought that was kind of poetic. So this is what those production platforms look like. They're insane. They're like these crazy vampires, and they have all these tentacles going down, and they connect to all the production wells. So a production platform first drills the well. That's what went all wrong in for British Petroleum. We'll talk about that Wednesday. And then after the drilling's done, it's capped, and then these production platforms come and siphon off the oil from the different wells. And so that's Thunder Horse one, I think, has 7 or 16 simultaneous production risers that can operate. All right, I think we're out of time. Sorry about that. Questions about the midterm? Did any of you have a chance to look at it? Yeah. We can save that for Wednesday.
Thank you, Professor.
Yeah.
Thanks, bro.
Thank you.
Yep.
Nice one.
Can I ask a question about today's lecture?
Yeah, by all means.
I was trying to follow while we were talking about distillation. The things like tar or roofing, the stuff that we were using for those things, are those actually getting distilled, or are they just like getting turned more liquid than they were?
Yeah, they're just getting turned more liquidy. It's picture like kind of melting a candle wax or something, and then it just runs off the base of the distillation tower. Good question.
Thanks.
Yeah.
Thank you.
Yep.
I have a quick question about the midterm. I think you answered this in a previous lecture, but I'm not really sure. The main 3 questions, or the main 3 equations we need to know, are the main 3 ones we went over, right? The change in energy, the power equals energy over time, and then I forget what the third one was called.
Efficiency.
Yeah.
Efficiency is get over pay and make sure you use the same unit. So like kilowatt hours over kilowatt hours.
Okay. And those 3 will allow us to do pretty much everything on that. Okay.
Yep. Yeah, the main one you really need to know is the power equals energy over time. You'll
Okay.
use that pretty frequently. Sometimes in a combination of them, you have to figure out how much energy you need and then the efficiency, etc. But yeah, we'll talk about it Wednesday. Have a look. It looks like there's another question. So once we open the midterm, do we have to finish it in that session? No, you have 5 days to do it. You turn it in as a PDF, same as the homework. So you download the PDF, work on it, pen and pencil for a while. And then once you're feeling good about your answers, type it up, submit it as a PDF, you're done.
And I think that Rosie was also asking earlier about the content, this week's content that we're going over in lectures. That's not included in the midterm, correct?
Not included. And yeah, maybe this will be a few qualitative questions on the final, but this is mainly just gearing up to the rest of the class, which will be renewables and climate change. So we're learning about what we're using today, and then we'll talk about why it sucks, and then we'll talk about what we can do to make things better.
Thank you, Charlie.
Yep. All right. Have a great week. Good to see y'all.
Thank you, Charlie.